guys, so in this video we are going to go over your Unit 1 test review. So let's get started. Number 1, put the following numbers in ascending order. So we know that ascending means we're going to be going up, so that means we're going to go from least to greatest. So let's look at the numbers we have here. So we have a negative square root of 121. So I know that the square root of 121 is 11, and because this negative is outside that square root sign, this means that the value of this number is negative 11. The next number is negative 54 fifths. So to figure out what the value of this number is means we need to come off to the side and divide. 54 divided by 5. Fractions are just division problems. So we're going to divide. And we get 10 and 8/10, but this is a negative fraction, so that means that this is a negative 10 and 8/10. We already have this in a decimal format, so it'll be easier to compare. And then we have 6 and 42 hundredths. And this last one, we're going to have to divide again, so 23 divided by 3. So the first thing I'm doing is I'm going ahead and I'm converting them all to decimals. It's easy when we convert them to decimals because you can look at the place value of the numbers. So let's divide here. So this would be 7. Just 2 left over. I know this is going to be repeating. All right, so this is going to be 7 and 6/10 repeating. So we're going from least to greatest, and we have positives and we have negatives. So I know that my least numbers are going to be the ones that are negative. The smallest value is going to be the one that's furthest away from 0 on the number line. So I like to think about it as being which number is the most negative. It's like it has the least value, but the number looks big because it's further away from 0. And so that would be negative 11 would be my least value because it's furthest away from 0. And we always want to rewrite the number in its original form. All right, so we've used this number. The next number is going to be the next negative that is the most negative, or the one that's furthest from 0. So that's going to be this negative 10 and 8/10. And I'm actually noticing something. It looks like these numbers are already in ascending order. The next number is going to be this negative. It's the last negative that we have. And then we're going to do our positives. So if we're going from least to greatest, 6 is less than 7. So that means that 6 and 42 hundredths. And then 23 thirds. That is really funny. Our answer is the numbers just as they were written. They were already in ascending order. I don't know if that was a mistake or not, but we just proved our answer by showing some work. Number 2, Elizabeth needs to rent the largest round table for banquet hall. The table are the sizes listed for the tables. Which is the following is the largest? Okay, so we need to figure out what the value of all of these are. So this one is 30.5 times pi. So we know that pi is about 3.14. So if we have a number next to pi, that just means that we need to multiply. So I'm going to come over here and I'm going to multiply 30.5 times pi. And it tells us to use 3.14 for pi. So let's go ahead and multiply. Remember, when you multiply decimals, you don't need to line up the decimal points. You just line up the digits. We're going to multiply like normal. Then we're going to add up our numbers here. The last step is to count the numbers after the decimal place, and we have 3. That means we're going to move our decimal 3 times, 1, 2, and 3. So this is approximately 95 and 77 hundredths. Okay, here we have 93 1/3, And then we have 32 and 1/10. So it looks like the largest is going to be A. All right, number 3, write 2 true statements and true false statements about the diagram. So for this one, you can have a lot of different answers. If I'm looking for 2 true statements, you could say, all rational numbers are real numbers. Because I know that this circle here that is rational numbers, this is inside of the circle that's real numbers. And I know that that's true because if you look at your notes, we know that all rational numbers, all irrational numbers, they're all considered, or they're all a part of the real number system. So one statement could be that. Over here, first we need to recognize that this is a true diagram. This one right here, this one's false. Okay, so this is false because integers, not all integers are whole numbers. Whole numbers are all positive numbers, not including decimals and fractions. So if it's a decimal or a fraction, we know it's not a whole because it's a part of something. And so whole numbers are positive. Whole numbers are not negative. Integers are negative and positive whole numbers. So this should be the other way around. This should have integers here, whole numbers here, because all whole numbers are considered integers, but not all integers are considered whole numbers. So for a true statement, you could say, -5 is an integer, but not a whole number. That's a true statement. For a false statement, you could say, all integers are whole numbers. That's false, because we know that's not true. But mainly what I wanted you guys to recognize on these diagrams is that this one over here is true, and this one is false. This is not an accurate representation of our number system, okay? And you can see that too by looking at your notes, but your statements will vary for number 3. Number 4, which point is most closely represented to the square root of 18 on the number line? So we're going to approximate the square root of this number because it's not a perfect square. So to do this, we are going to ask ourselves, what perfect squares does the square root of 18 fall between? So I know that this is going to fall between the square root of 16 and the square root of 25. The square root of 16 is 4, and the square root of 25 is 5. So we know that our answer is going to be somewhere between 4 and 5. All of these points are in between 4 and 5, so we need to figure out where will this number be closest to. So I see that 18 is just 2 away from 16, and it is 7 away from 25. So that means the square root of 18 is going to be closer to 4 than it is to 5. So we know that D is not my answer. And C, this would mean that the square root of 18 is really close to being in between these two numbers, and it's not. It's more closer to the square root of 18. And because it's only 2 away, I would say that the answer would be A. And we can check this by pulling up our calculator and putting in the square root of 18 to double check. So it's about 4.2, which is about point A. Not exactly, but pretty close. Point A is the closest. All right, number 5, write each set of numbers in descending order. So descending means that we're going to be going down. So this is going to be from greatest to least. So let's look at the set A. We have 0, negative square root of 2, the square root of 5, and then we have 13 over 4. So we need to figure out, well, I guess if we're going in descending order, greatest to least, we know that this negative is going to be the least because it's the only negative in the set. And then 0 is going to be the next least. So we could kind of work backwards for this one. This is one where we can just kind of use our common sense and what we know about numbers to list them. We don't actually have to convert them all. So really, I just need to figure out from these two numbers which one is bigger, which one's smaller. So let's go ahead and figure out 13 divided by 4. Divided by 4 is 3 25/100. So now I'm going to approximate the square root of 5. So the square root of 5 is going to fall between the square root of 4 and the square root of 9. The square root of 4 is 2 and the square root of 9 is 3. So that means that this number is somewhere between 2 and 3, which means that it is smaller than 3.25. because this number is greater than 3. It's not in between. So the biggest number here is going to be 13/4. The next biggest number will be the square root of 5. And then we were able to list those two. All right, let's look at B. 3, we have the square root of 10. I don't really know the square root of 10, so let's figure that out really quick. The square root of 10 falls between the square root of 9 and the square root of 16, which means it's going to be a number that's between 3 and 4. And it's going to be a number closer to 3. So this number is just a little bit bigger than 3 because it's very close to the square root of 9. But we do know that it's bigger than 3. So that tells me really quickly that this number is going to be the greatest because it's bigger than 3. The next greatest number will be 3. Then we'll have this 3/4 because 3/4 is not even quite one whole. And then our negative number will be the smallest. And last but not least, this time we have some decimals and we have some fractions. So I'm going to start with the greatest numbers. The greatest numbers, if we're looking at our positives, the biggest number is 2. And the next positive biggest number would be 75/100. So really we're just tossing up -3/7 or -3/2. So this is improper, which tells me, I just know 3/2 off the top of my head. It's -1.5. So really we just need to figure out which one of these is furthest from 0 because that number is going to be the smallest or the least. And so because this -1/2, it's a negative whole, we know that this number is going to be the smallest and furthest away from 0 because this one is not quite -1. It's just a fraction. And so this number is going to be closer to 0. This number is going to be further from 0, meaning it's smaller. Okay? All right, I think I have enough time in this video before it cuts me off to do number 6. So it says, name a decimal value that would fall between these two. So once again, there's multiple answers for this one. But what I like to do is I like to just go ahead and convert them both to the same form. For me personally, because percents are kind of more like whole numbers, they're easy to compare, I'm going to change this 5/8 to a decimal by dividing, and then I'm going to make it into a percent. And there's multiple ways you could do this. It does not have to be done this particular way. You could make the other one a decimal. And this is a benchmark fraction, so you might have already known that this is 625 thousandths. Uh-oh. So if I want to convert this to a percent, we're just going to move our decimal 2 places or multiply by 100. So this is 62.5%. So if I want to pick a value that's in between, there's a whole bunch. You're just going to pick a number that's been in between 12.5% and 62.5%. So I could pick 20%, I could pick 60%, 40%. If you made them both decimals, you could do that too. This is 0.125. We just moved the decimal 2 places to the left. And you could name a decimal that's between these 2 decimals as well. These percents could be written as decimals, so we could also say that 2/10 is in between those two, as well as 6/10. Okay? So that one we're just comparing some rational numbers.